Hi, this is a video of me playing around with pandas and on the data of the John Hopkins University. And I think the main difference is from what you usually see is that I took also data from Worldometer, which basically gives me the amount of inhabitants per country. And yeah, you find the links to the original data and also the source code link to GitHub for the analysis program. So the program with I did all the pictures I will go over now for the discussions of the data, where you can download it and also do it yourself. So what I essentially did is I took the data from the John Hopkins University and concerning the amount of deaths and the amount of infected people, and I took the data from Worldometer for the total inhabitants per country, and I divided first all the data from the John Hopkins University per country by the amount of inhabitants. So that's the main difference. And then I basically filtered the data. I eliminated all data from countries where nobody has died yet. And I took only data from countries with inhabitants more than 30 million people. And I only took also countries into calculation where I actually know the amount of inhabitants, so which is kind of the intersection between the two tables from John Hopkins University and Worldometer. And basically the reason for the 30 million country is that, well, if I visualize the data and also take all the smaller amount of countries, it kind of gets cluttered. And because of the smaller sample size per country, also, of course, I get more noise artifacts in there. And the last thing I did is I also took Peru out of the analysis. And why I did this, I will explain later on. So let's take a look at the data. So this is the first visualization that we are using. And well, basically what I've done here is that I put points on the map for the different countries that are represented. And the size area of the point corresponds to the amount of inhabitants that, that live in that country. And the color indicates some feature that I want to visualize. So I start with something relatively simple here. So if you take a look at the data from the John Hopkins University, the log starts at 22nd January of 2020, and my log finishes now at the end of August. So the first visualization I did here is how many days since the beginning of the log, so since the 2020 January, lasted till the first infection was reported by that country. And that is visualized here from the scale from 0 to 60, I think. Yeah, so that's the color you see on the right side. So how does it work? If we take a look at, of course, it started in China. And from China, as you can see, it spilled relatively quickly over to neighboring countries like Thailand, Japan, also Russia and India also, and Western Europe and North America. So that was where it spilled quickly over. And then you see it kind of spilled over to Mexico, South America, and also North Africa. And from there it went to kind of Eastern Europe was the next part, and Southeast Africa, so except for the country South Africa itself, it was pretty much the last part where it surfaced. But anyway, so that all happened kind of in 60 days. This visualization, I would say it's kind of the most interesting of the whole data set, because what I did here is I divided the total amount of people that died during that time period, so from end of January till end of August, by the amount of inhabitants of that country. So you see here the data ranges from somewhere like 1 in 10,000 people up to 6 in 10,000 people. And yeah, what we see here basically is like Eastern Europe, Asia, and Africa are pretty much low, are relatively low. And yeah, you see it's a bit of going up somewhere like Iran and Iraq. And we see some activity in North America and South America. And we also see some activity in France, but actually the spike is in Spain, United Kingdom, and Italy. So that is kind of counterintuitive, because if you take a look at the data, the absolute data, then it's like the US is pretty much on the top, and India is very high also. But the point is, of course, that those countries also have a large amount of inhabitants. So it's like the probability that you have died in one of the countries because of COVID-19 is here visualized in this picture. So yeah, so the probability in Spain, United Kingdom, and Italy would have been higher than in Brazil, and that is higher than in North America, or more specifically US and Mexico. So Canada, that you see also somewhere, it's represented a point near the Hudson Bay, is also relatively low compared with basically Europe towards the northeastern side, starting from Germany, and also Africa and Asia. This brings us to the next point, which is a visualization where we show the amount of reported infections per inhabitant. So that ranges somewhere between a kind of a 0.25% to 1.75%. The interesting thing here is that kind of looks different than the visualization we've seen before. So it's kind of again like Africa and Asia and Eastern Europe are quiet, but there's not so much going on in Western Europe here, maybe except for Spain, that gets a bit higher. So the two biggest countries, or the two most important parts where the most infections per inhabitant are reported, are Brazil and the United States. So yeah, that's kind of diverges from the information we get from the relative amount of death from the people. This brings us to the next visualization, where I basically divided the amount of people that died by the amount of people that got reported as infected. So this ranges somewhere between 2% and 12%. But at this point, I would be very cautious about some kind of interpretation concerning the basic characteristics of the pandemic, why we will see later on if we take a look at some other data. But what we can see here is that southwestern Europe, so especially Italy and United Kingdom, have a very high ratio at that point. And relatively high ratio we also see in France and in Mexico, and also a bit in Spain. And so it's like China and Indonesia are also a bit higher at that point. But interesting here is that US and also South America has a relatively low ratio here at that point. As I said, especially keep this with Europe on mind, so that will be interesting if we take a look at a bit later on at further visualizations. I want to explain why I took Peru out of the data set. So in this case, this is also deaths per inhabitant. Peru is still included. And you see this as a bright yellow spot here on the northwest coast of South America. So the kind of amount of deaths per people is actually significantly higher than in any other country. So question is, why did I take it out? This is also the point where we go over to time sequence analysis. So there are a couple of visualizations now coming where I painted the amount of infections above the amount of deaths. So both again occurring per inhabitant. And if we take a look at Peru, we see something strange going on here. So, well, the amount of infections is kind of rising, and there are basically 2 days there where we have a very large amount of people dying at those 2 days. So yeah, I kind of found that suspicious, and that's basically the reason why I took this data set, this country out of the analysis. Okay, let's take a look at some more time series. This is the data set of Vietnam. And you see also something suspicious going on there. So there is somewhere behind day 200. There is obviously a day with negative amount of dead people. My initial thought was, okay, I obviously have a bug in my program, but if you take a look at the browser on the John Hopkins University and visualize the amount of dead people accumulated and the amount of dead people per day, on the amount of dead people per day, you don't see a negative value, but if you switch over to the accumulated per day, then you see that there is at that point actually a day where the amount of dead people is fewer than on the previous day. And the data you get from the GitHub server with the from the John Hopkins University is actually giving you the accumulated amount of numbers. So what I did here is I got the per day number by always building the difference from the previous day. But anyway, so this artifact you can find also in other countries on a per day basis, but it is actually a part of the data source. Here's another example of the raw data here from Tanzania. And what you can see here is that, well, the curves are jumping pretty much up and down. So that's one of the more extreme examples, but no matter at which country you look, especially on the weekends, the numbers get smaller. And so it kind of gets uncontinuous. And so what I did is then that I said, okay, before I do a more deeper analysis on the time series of the data, I kind of low pass filter it here did it by applying the moving average and going from 7 days from the past till 7 days in the future, just to kind of smoothen the curves. So that is what I did here. So I smoothened the curve. You see here at the example of the United States. And what I additionally did is these are the red spots. I kind of tried to look for the first relative maximum in both curves. And yeah, a relative maximum is defined by the fact that the value must have at least 30% of the value of the total maximum, and there must be no larger value than the indicated value in the 20 days before and after the date. So this could mean that there is no relative maximum in the data set at all, because if the maximum is closer to 20 days, either from the start or the beginning, there is no relative maximum that can be detected. The idea why I did this was that, well, my original thought was that well, you have people that get sick, and a certain amount of people of those who get sick will recover, and a certain amount of people will die. So I would expect that the death curve kind of should be a translated version of the infection curve. And the usual way on how you can kind of establish this is by shifting one of the curves and find the shift value where you get the maximum correlation coefficient. But if you take a look at some of those curves, they don't really match at all. So yeah, so that's why I didn't dig deeper into this idea, but I kept to the idea that I want to detect the first local maximum of that curve. So that is kind of the things that happened when the pandemic in that specific country started till, yeah, they managed to kind of get the infection started to get down, and or the amount of dying people to get down. So with the information about the local maxima, we can do further map visualizations. So the first thing I did here is basically just a labeling visualization. All countries where I have detected a local maximum on the infection curve and on the death curve are labeled yellow, so that are most of it, and everything that is labeled blue doesn't have a local maximum. So we can take a look at here at the examples of India and China, what this actually means. Yeah, here with China, we see a local maximum on the death curve, but not on the infection curve. But there is visually a local maximum on the infection curve. Reason being why an local maximum on the infection curve is not detected here is that the this local maximum that is pointed here is closer than 20 days away from the beginning. So that's why it is according to, because there's this 20-day distance rule, not detected. But that is kind of the only data set that doesn't have a local maximum because of that rule. What we also see here is an artifact on the death curve somewhere close to the 100 days into the infection, where we have a sudden spike again. Okay, so that was China. And with India, we kind of have the opposite effect. So we don't have either a local maximum in infection nor in death, because both curves are still rising. So this means that that's also the case for the other countries, is that either there is no local maximum yet developed, or also for some countries it is already developed at one point, so the curve is going down, but this local maximum is less than 20 days away from the end of recording. So that's why those countries do not have either a local maximum on the death curve or on the infection curve. And for further analysis, I will also take out those countries. And so for the analysis of some map pictures that are based on the information where those local maxima are. This visualization shows the time that passed between the first reported infection and the time when the first local maximum has been reported. So that's why China and India are not included here, and also other countries, because as I said, I filtered them out if they don't have a local maximum on their death and infection curve. So in general, what we see here is there's a relatively quick point of time between the beginning of the infection and when the first maximum occurred in North America and Western Europe, and also in Southeast Asia, with the exception of the Philippines, also a relatively short amount of time. And it took longer in South America and Mexico, and also in Africa, and also a bit of Russia. But anyway, so the response was, or the amount of time was relatively short in Europe and North America. This picture here is the amount of time that passed between the first person to be reported dead and the local maximum of dying people reached. So essentially, it tells the same story as the analysis of the previous picture with the infections. Now, this picture shows the relative amount of people dying on that first local maximum. So the point when basically the pandemic started and reached its first local maximum at that specific country, how many people compared towards the amount of inhabitants died on that day. So what we see here basically is Asia and Africa relatively calm. South America and North America a bit higher, but especially high is Western Europe, so Italy, France, United Kingdom, and especially Spain. So remember when we talked about on the previous picture about the amount of dead people, relative amount of dead people in that country compared towards the amount of reported infections. So this kind of looks, kind of correlates with this picture. A similar story is told by that picture. So in this visualization, I took the relative amount of people, of dying people at that local maximum day, and divided it by the time between the local maximum day and the day when the first dead person was reported. So it is kind of an indication of how overwhelmed the country was with the incoming pandemic. So also here we see that in Western Europe the values are the highest. At the end of the talk, I just want to try to take a look at some of the curves and kind of qualitatively try to categorize them. So this becomes more a matter of interpretation now. So there are a set of countries that have not seen their maximum yet, or are pretty much on the first local maximum yet on both curves, or are pretty much on the verge of seeing that. So that is, for instance, the case here with India, what we have already discussed. Then we have a couple of countries that have seen their local maximum on infections and death, but they are still, compared to that, relatively high and slowly declining. So that's the case for Russia. A comparable situation, more or less, is South Africa, whereas here the local maximum is on both curves is a bit more articulated than it was in the case of Russia. More extreme form of that pattern we see in Brazil. So Brazil is kind of building a high plateau, or very slowly declining plateau, on infections and especially death. The pattern one can observe in many Western European countries is now that there was a local maximum in infections and death, and that there is a rise again in infections. But there is no rise or significant rise in the amount of dying people observable. Germany kind of follows the same pattern as France. So we see a small rise here in the amount of infected people again after some time, without a rise being observable in the amount of dying people. A variation of that pattern we see here at the example of the United States, where after a first local maximum we see a local minimum, and then again, like in France, a rise, and Germany a rise in the infections, but a lot higher rise in the infections. And that also manifests itself here in a rise again in the amount of dying people, but to a far smaller degree than at the first maximum. A similar pattern to what we have seen from in the US is happening in Japan. So here we also have a higher rise in infections that is also accompanied by a rise in amount of dying people. But actually these are the only two countries I saw in the list. So with the filtering criterion here of 30 million people that follows this pattern. Okay, with this analysis, I'm also finished with discussing the data set. Despite of being quite of a not so nice subject matter, it's actually interesting to play around with pandas on data. Yeah, thank you for your attention.